So you can ask your doubts. This was a pop quiz 7, the MCQs pop quiz 7. This is the MCQs pop quiz 7. If you have doubt in question 1, question 2, any doubt? Question number 2, question 3. This is a MC. These are the MCQ. This is a pop quiz related to MCQs. Pop quiz 7. Question 1, 2, 3, no doubt. Question 4, any doubt? And question number 4. Question 3. And question number 3. A tennis ball is hit so that it leaves the racket with a velocity v at an angle of a theta to the horizontal. The vertical component is Vy. What is the magnitude of the horizontal component? How we can work out the magnitude of the horizontal component? So the horizontal as a vertical component is given by, we have the two components. If we resolve the vector into the component, like this vector v is there, so the component which is with an angle, that will be written with cosine. So this is equals to v cosine theta. And the component which is opposite to the angle, that is equals to v sine theta. So one of the option that the horizontal component, magnitude of the horizontal component should be v cosine theta. That is one possibility. But we don't have the v cosine theta, like there is no option of, there is vy cosine theta, but not v cosine theta. So that's why this cannot be selected as answer. What is another possibility? That if we have the vector v is there and we know the vertical component of the vector which is vy, and we need the horizontal component of the vector, so we can also use a Pythagoras theorem because it is making a right angle triangle. So in a right angle triangle, the hypotenuse square equals to base square plus the perpendicular square. So if we need the horizontal Vx, Vy will move other side. So V square minus Vy square is equals to Vx square. If I need Vx, I will take a root, under root. So when we take a root, so under root or root V square minus Vy square is equals to Vx. That will give us the magnitude of the horizontal component. So D will be the right answer. Question 4, 5, any doubt? Question number 4 or 5, any doubt? Question 6, 7, or 8, any doubt? Question 6, 7, or 8? Question 8, okay. In question A, the diagram shows two parachutists, X and Y, which are moving vertically downward. The total mass of a parachute is Y, and his parachute is twice as the mass of X. At this moment, the air resistance is twice, like air resistance on this one is twice as compared to this one. Neither of the parachutists have reached a constant terminal velocity. Means there's a resultant force is acting because they did not reach the terminal velocity. So it means there must be a resultant force act. Which statement describe the acceleration of y compared to acceleration of x? So first, how we can work out the acceleration? First, we should know what is the resultant force. The mass of this one is m, the mass of this one is 2m. And the resistive force, the force which is opposing the motion, that is 2r here. As I mentioned, it is twice. At this moment, air resistance on y is twice. So if here resistance, here is r, here resistance is 2r. If the mass is double, like example, if this mass is m, this mass is 2m. So it means weight is also, like the weight of this one is w, the weight of this one will be 2w. Because both of them did not reach the constant velocity, so there must be a resultant force. And for the parachutist, the resultant force is always acting downward. Uh, for example, when they're moving downward, the resultant force is downward. And when they open the parachute, the resultant force is there, which is opposite to the direction of motion, which oppose the motion, and eventually they reach a constant or a terminal velocity. Now, if you want to work out the resultant force here, the resultant force, what is the resultant force on X? So it will be R minus W or W minus R. You can do any way, other way around as well. For this one, what is the resultant force? The resultant force will be equals to 2W minus 2R because the weight is twice and the air resistance is also double, as I mentioned in the question. And we know according to Newton's second law, no, both of them, when you compare the skydiver, when the skydiver jump, his weight is acting downward and air resistance is acting upward. Eventually, he reach a terminal velocity. And the moment usually what happened when we open the parachute, the air resistance is more than the weight. So that's why air resistance minus weight will be equals to the resultant force. If the parachute is opened without reaching the without reaching a first terminal velocity, in that case, because in the question they did not specify, and neither of the parachutists has reached a terminal velocity, so weight is acting downward, air resistance is acting upward. The moment they open the parachute, in that case, I can say weight is greater than the air resistance. But because when the air parachute is open, the air resistance should be more. So because the purpose of the parachute is to reduce the speed. So it has a purpose to reduce the speed. So means the air resistance should be more than the weight. So it will decelerate and eventually it reach a constant velocity. Like it will decelerate and eventually it reach a constant velocity. So purpose of the parachute is to slow down. That's why when I drew, I said like this is R, here weight is W, and here this is 2R, and the weight is W, 2W, because the mass is twice. Why I consider the upward force to be greater? Why I compare the upward force should be greater? Because the purpose of the parachute is to slow down. So means the resultant force will always opposite to the direction of the motion to decelerate. So when I write for the first one, the drag force, yeah, I will simplify like R minus W is equals to resultant force here. And for this one, 2R minus 2W is equals to resultant force. Now, but we need an acceleration. The question is about acceleration. So according to Newton's second law, the resultant force F is equals to ma. So you can say R minus W is equals to ma. And here also 2R minus 2W is equals to ma. But what is the mass here? They mentioned this has a twice mass as this one. So when we substitute ma, we will substitute 2m because the mass is twice m. And now we simplify this. So if we need an acceleration, it will be R minus W divided by M is A. What about this one? 2R minus 2W divided by 2M is equals to A. If I take 2 common, so it will be R minus W divided by 2M is equals to A. 2 will cancel with 2. So it means R minus W divided by M is equals to A. So what it shows? It shows we get the same expression. So if we get the same expression, it means the acceleration of the parachutist X will be equals to acceleration of the parachutist Y. Or actually it should be a deceleration, the right term, because they will decelerate. So the deceleration of parachutist X will be same as the deceleration of parachutist Y. Is it clear? Is it clear, this one? Why deceleration? Because what will happen practically when a skydiver use a parachute, he want to slow down and reach a lower terminal velocity. So it always decelerate whenever we open the parachute because the air resistance is greater than the weight, so we decelerate rather than accelerate. But because it's just a comparison, so using a term acceleration, acceleration upward or deceleration downward, the same meaning. Is it clear to everyone? Question 9, any doubt? 9 or 10? Question 10. Question 9, what you have to do, because I mentioned it's an elastic collision. When we say it's a perfectly elastic collision, so two things should happen. Number one, the momentum should be conserved. Like momentum before and after should be same. And the second thing is kinetic energy should also be conserved. The kinetic energy before and after should also be same. So when we check, you have to check, like example, what is the momentum before? 4 into 0.5, so that is 2. And here the momentum is 0. So before is 2, but what about after? The total, the two objects stick together moving at a speed of 2 and the mass is 1. So the momentum is same, conserved. But what about the kinetic? Momentum is conserved for A. But what about the kinetic energy? You have to use a formula half mv square. So what is the kinetic energy of this one? So it will be half, mass is 0.5 and speed is 4 square. So 4 square is 16 times 0.58 and 8 divided by 2. So we get 4. Here the joule, so this is 4 joules of kinetic energy, there 0. What about this one? It will be half, the mass is 1, the total mass, and the speed is 2 square. So when we simplify, 2 square is 4 divided by 2. So we get 2 joules. So means the kinetic energy is not conserved. The total kinetic energy before was 4 and the total kinetic energy after is 2. So it means momentum was conserved, the kinetic energy is not conserved. So means it cannot be A. Same way, it cannot be B as well, because in B, when I work out the kinetic energies, even the momentum is 0 before and after, but the kinetic energy, when you work out, it won't be same. Why? Because this object is not moving, so kinetic energy is 0. But here two objects are moving. When we find the sum of the kinetic energy, we don't consider a direction because kinetic energy is a scalar quantity. So it cannot be B as well. So then you will check with C, like the momentum first is the momentum should be conserved, second is the kinetic energy. So what is the momentum here? 2 into 0.5, which is 1, and here 1 into 0.5, so this is equals to 0.5. But this is in opposite direction, so it will be 0.5. So what is the total momentum before? The total momentum before is 0.5 towards right. So total momentum after should also be 0.5 towards right. So this, when we take a product, that will be equals to 1. And when we take a product, that will be equals to 2. But when we subtract, because as you can see here, right hand momentum is greater. So the total momentum will be, if the right hand direction is positive and the left hand direction is negative, so when you simplify, you get 1. So the momentum itself is not conserved in option C. So what we are left with option D. And when you check the both kinetic energy and the momentum, the sum of the momentum and the kinetic energy, you will get the same answer. It's not like, I'm not saying momentum equals to kinetic energy. I'm saying the sum of the momentum before will be equals to sum of momentum after, and sum of the kinetic energy before will be equals to sum of kinetic energy after. Because momentum is a vector quantity, so direction is also important. So if right hand side you're taking as a positive, the left hand side you will take as negative. So example, if a right hand side I'm taking positive, so what is the momentum here? 2 into 1, which is 1, towards right. So I take positive. 1 into 0.5, so which is 0.5, but it is opposite direction, so I'll call negative. What is the total of plus 1 and 0.5? So I will get 0.5 positive, means that is towards the right hand side. Same way, this is opposite, so 2 into 0.5 minus 1. And 3 into 0.5, so it is equals to 1.5. 3 into 0.5, that is 1.5. So this is towards the right hand side. When I simplify, so minus 1 plus 1.5, so I'll get 0.5 positive. So that's towards the right. And then I will take the kinetic energy. The kinetic energy will not be conserved. Momentum will be conserved. Sorry, the kinetic energy will not be conserved. But like you take half mv square for each and add them and half mv square for each and add, you will not get the same result. In question 10, the cylindrical block of a wood has a cross-sectional area of A and a weight W. It's totally immersed the water with an axis vertical. The block experiences a pressure PT from the top and PB from the bottom. What is the upthrust? So when object is there, which is completely immersed, this is a cross-sectional area from the top and from the bottom. There's a pressure from the top. What is the pressure from the top? That is PT. What is the pressure from the bottom? That is PB. We want to find in the question, we want to find the upthrust. So whenever object is completely submerged, what is the concept of the upthrust? Upthrust is the weight of the liquid displaced. How much liquid is displaced by the object when the object is completely submerged? What weight of a liquid will come out? That is known as the upthrust. So I can say upthrust will be equals to weight of the liquid displaced. What about the weight? Weight is what? Like weight is also a force. So when the object is completely submerged, what is the force experienced by the object? How you represent the force? The force, we have the formula that pressure is force over area. So if I want to find the force will be equals to pressure times area. When pressure is multiplied by area, I will get the force. And that force will be equals to the upthrust. Because upthrust is actually a reaction force of the fluid, and how much object experience the upthrust, that is always equals to weight of the liquid displaced. So when the object is completely submerged, the upward force which the object experience when it is completely submerged, that is equals to the upthrust. And that force is equals to pressure of an experienced by an object multiplied by area. But this object is experiencing two pressures. One is a pressure from the top and another one is pressure from the bottom. So what will be the total pressure? The total pressure will be the difference of the two pressures. So upthrust is equals to weight of a liquid displaced, or we can also say the upthrust is equals to upward force with the object experience. And if I need an upward force, the force can be in terms of a pressure, that is a pressure times area. So what is the pressure here? The object is experiencing a pressure from the bottom and object is experiencing a pressure from the top. The difference of the pressure, the difference of the two pressure will be the total pressure which object experience. Like if I say there's a upward pressure from the bottom, there will be upward pressure of 80 Pascal. And there from the top, there is a downward pressure of 20 Pascal. So what is the pressure, the overall pressure this object will experience? So the overall pressure this object will experience will be 80 minus 20. So same thing, the pressure experienced by this will be the bottom pressure minus the pressure at the top, or the difference of the two pressure, that will give us the resultant pressure. And multiply by the area, what we will get? We will get the upthrust. So upthrust will be equals to the difference in the pressure times the area will get the upward force, and that upward force is actually the upthrust. Why is the bottom pressure first? Because when we talk about upthrust, upthrust is always the force which is acting upward. So if I know the pressure from the bottom and I know the pressure from the top, if I take a difference top minus bottom, I will get the down thrust. Like I'll get the what is the downward force. But I want an upward force. That's why the pressure from the bottom, which is acting upward, and the pressure from the top, which is acting downward. When I take a difference of these two pressures, I will get the net pressure. And the resultant pressure multiplied by the area of this, the cross-sectional area, will get the force. And that force is actually what? This force is the upthrust. Is it clear, this one? In the question, it is written vertical axis because this is a horizontal axis, means it can be like this. But in the question, they mention it's a vertical axis, so means the object is submerged in this manner. This is a vertical axis. This is a horizontal axis. So they mean that the object, because the expression will change if an object is submerged horizontal axis or it is submerged vertical axis. So the expression will change. So the object is submerged in a vertical axis means in this manner. Yeah, if you substitute the pressure, that's right. If you substitute the pressure into upthrust formula, that will also give the same result. It won't make difference. Question 11 or 12, any doubt? Question 11, 12. In question 11, look, torque and moment have a same formula. Moment of a couple is different thing. But torque and a moment have a same formula. A mass of a 500 gram is attached at the end of a length 5 meter long. The rod is pivoted at a distance 25 centimeter. What is the moment of the turning effect? In question 11, two forces each of a magnitude F and disk of a diameter D is shown. What is the torque? Here torque means moment of the couple, because where two forces are acting in opposite direction and they produce a turning effect in the same direction, we call torque or moment due to a couple. So how we can find a moment due to a couple? Whenever we need a moment due to a couple, it is a force multiplied by the distance between the two forces. So the force multiplied by distance between the two forces, that is the moment due to a couple or torque. So what is the force? The force is F. What is the distance between the two forces? The perpendicular distance, that is S. So F multiplied by S will give us the torque or the moment due to a couple. So it's always the case, the perpendicular distance between the two forces multiplied by the force, you'll get the torque, the turning effect, or the moment due to couple. Is it clear? In question 12, you need a turning effect. So the mass is given 500 gram. First, I have to convert into kilograms, so it will be 0.5 kg. Then I have to, because moment is a force into distance, so I need a force. So what is the force here? It will be the weight. So we multiply by 9.8. So 0.5 multiplied by 9.8. So 0.5 times 9.8, 4.9. So 4.9 Newton is a weight. So for the weight is acting, which is 4.9 Newtons. And we take a distance from the point of rotation or a pivot. If the total is 1.5 and this is 25, so this will be how much? It will be 1.25 meters. Because total is 1.5, 0.25 centimeter, 0.25 meter or 25 centimeter here, 1.25. So we need the turning effect. So it is force into distance. So 4.9 multiplied by 1.25. So it will be C will be the answer, which is 6.1, rounded off answer, 6.1 Newton meters. Question 13, question 14, any doubt? Question 13, okay. Question 13. A beam QR is held in a position PQ, as you can held by a wire PQ. The structure is used to form a crane supporting a stationary load of a 4 kilonewton. So, what is the force exerted by beam QR on a point Q? Look, we need what is the force? This force we need. Because what will happen as it is stationary? The 4 kilonewton is there, and this tension example T will be there. And the result of these two, there will be a resultant force, like there will be a force in this direction on point R. And because it is stationary, so if it is stationary, there will be another force will be there in this direction to balance that. Like if I have a tension, say I have a tension here and I have 4 kilonewton. So tension T is there and a 4 kilonewton. So the resultant of these two forces, say result of these two forces in this direction, which is acting on point R. Then the question is, what is the force exerted by the beam on point Q? So the beam will apply because there is a force on the beam according to Newton's third law. There will be a reaction force, so there will be force by the beam which will be in opposite direction. So that force will be F. Is it clear till this point? The forces, the direction of the force. Then I will solve a question, but first you should understand the direction of the force. Now we need, so this tension we don't know. This force also we don't know. But this force is making an angle. If I take an axis here, so this will be 30 degrees. Why? Because as you can see, transversal intersection, like when two lines intersect, so the angle form, opposite angle form are congruent. Like example, if this is alpha, this will be alpha. Or if this is beta, this will be beta as well. So when I draw this force F and I resolve this force into the component, like work out the angle. So this force F is there and it is making angle theta, means 30 degrees. So these two angles will be same. So this force will have the two component, one of the component of this force, which is with an angle that is cosine. So I can say this will be equals to F cosine theta. And one of the component will be perpendicular, that will be equals to F sine theta or F sine 30. Instead of saying theta, I can directly write 30 here. So what does it mean? Because it is held stationary, so there is no resultant force. So I can say that this T, which is acting towards left, is equals to F cosine 30, which is towards right. And this F sine 30, which is acting upward, balances with a downward force, which is 4 kilonewton. Because all of the options are in kilonewton, that's why I did not convert the unit. I kept it in kilonewton because all the options are in kilonewton. So I'll keep it 4. So it means 4 equals to F sine. The first equation, I have two unknowns. I don't know F, I don't know T, so I cannot use this equation. But the second equation, only one unknown is there. I know theta and I have the value 4, so I can work out F. Yeah, 4 kilonewton is T sine 30. That's right. So 4 kilonewton not T sign, it's F sign. The T, it's not T, it's F. Because F is a reaction force. This 4 kilonewton and the tension will produce a resultant force in this way, and there will be a reaction force on the wire in opposite. So this F is not T, that is a reaction force of R. But this R and F will be equal, as it's a reaction force and Newton pair force. Like a wire exert a resultant force R, and then there is a reaction force F on the wire. There is no vertical component of the T. T is only horizontal. So there is no vertical component of the T. So I can say F4 is equals to F sine 30. So 4 divided by sine 30, I will get the value for F. What is the value for F? 4 divided by sine 30. So it will be 8. So D will be the right answer. Is it clear, this one? So, yeah, I will explain again. See, a 4 kilonewton is acting downward and a tension T is acting in this way. So there will be a resultant force. There will be a resultant force of these two in this direction. And the beam, because the question is, what is the force exerted by the beam on Q? So if there is a force in this direction on the beam will apply an equal opposite force. So this will apply a force F. Because a Newton pair force. If we apply force on the object will apply equal opposite force. And this F is making an angle. If I take an axis here, this F will make an angle theta. So this F will have the two component. One of the component will be F cosine 30, and another component of this F will be F sine 30. So F cosine 30, which is towards right, is balancing the T. So it means T is equals to F cosine 30. Why I cannot use this formula to solve F? Because I don't know F, I don't know T. The tension is not given in the question. But when I use the vertical component, which is upward, so F sine 30 is acting upward, it balances with the 4 kilonewton, which is acting downward. Why I did not convert the 4 kilonewton into 4,000 Newton? Because all the options are in kilonewton. That's why I did not convert the units. So I have 4. I know the value of a sine theta, so I can find F. So it will be 4 divided by sine 30 will give us the value for F. That's why D will be the right answer. Is it clear? Because it is stationary, so the upward force equals to downward force. So this is the upward force equals to downward force. This is a force towards right. This is a force towards left. All the forces are balanced. Like there's no resultant force. The system is not accelerating. The next question, question 14. A metal cylinder totally immersed in a water is hung from a Newton meter. The cylinder of a length L is slowly raised, so we are moving it upward by lifting by the Newton meter. At the base of the cylinder, as the base of a cylinder moves from a line X in a water to a line Y above the surface, the reading of a Newton meter is recorded. The velocity is constant. So if the velocity is constant, what we can say, it means there should be no resultant force. Which graph shows the variation of a R with a distance? So if we work out the values, when it is inside, what are the forces acting? Weight is acting downward, that is one force. Upthrust is acting upward, that is another force. The force from the Newton meter, that is example you call R, the force which we apply by using, that is a R, which is also acting upward. And you can also say F, you can also say R, because we want a variation of R. and there will be another force, a drag force will also be there, because when an object is moving through a fluid, so there will be a drag force. What is R? R is also a force which we apply by using this Newton meter. So as the object is moving and it is moving at a constant velocity, so there is no resultant force. In the question, we are pulling an object upward. If I'm pulling an object upward, so example, my force is R, the upthrust is acting upward, the weight of this object is acting downward, and the drag force, the force which opposes the motion, is also acting downward. So the force which I am applying, I call that as a R. So there is no resultant force, as I mentioned, it is moving at a constant speed. So what I can say R plus upthrust, which is acting upward, is equals to weight plus the drag force. Or I can say R plus upthrust minus weight minus drag will be equals to 0. Why equal to 0? Because this object is not accelerating, or this object speed is not change, like it's moving at a constant speed. So if it's moving at a constant speed, the resultant force should be 0. Is it clear till this point, the forces? Till here. Now, upthrust. Upthrust depends on the density. How I got a formula, how I got the formula. Example, the force which is applied by a Newton meter is R. The weight of this cylinder is acting downward, W. When the cylinder start to move, because when anything is moving through a fluid, it will experience a drag force. And when object is submerged in a fluid, it will, or submerged or partially it is submerged, it will experience a force, upthrust. So because in the question they mentioned it is moving at a constant velocity. So constant velocity means there should be no resultant force. So the total upward force should be equal to total downward force. The upward force is R and U, which is upward, and the downward force is the drag and the weight. Or I can say R plus U minus drag minus weight is equals to 0, because this object is not accelerating. Now let's see how the value of, we want how the value of this R will change. Okay. So we want the resultant to be 0. First, the drag force. Does the drag force change? Look, drag force depends on two factors. Drag force depends on the surface area, and it also depends on the speed square. In the question, they mention it is slowly raised, so speed is very small, negligible. You can, and the surface area is not changing for the cylinder. So it means the drag force will not change. The drag force will remain constant. The weight of an object does not change. The upthrust when object is completely submerged, till the point the object is completely submerged, the upthrust will not change. So all the values are not changing. So what will happen to the value of a R? The value of the R should not change. So if we sketch the graph when it is inside or underwater, until it is underwater, the value of the